So let's talk about a little bit more about those security flavors. What are those security flavors and how does that apply to things like multi-protocol? How does VAST do multi-protocol? And really, what are the ins and outs of those different security flavors? So first off, let's go through and let's define what multi-protocol is. Are we talking just about I'm running multiple protocols on the same storage array? I got files, I've got blocks, I've got objects on that. And no, we want to do more than that. Do I want to be able to access files over only file protocols and objects only over object protocols? Meaning S3 is off by itself? Not really. We're talking about being able to upload files or objects over any protocol and accessing them over any other one. So I want to be able to upload something over S3 or write a file over NFS and then read it over S3 or write it over SMB and read it over NFS. All of those there. This is what we're referring to when it comes to multi-protocol. Within VAST, this slide kind of describes how we do things. With this, we've got our protocol layers, and the protocol layers, each one of the protocols is something that we author in-house. VAST maintains all of those in-house. Each one of the protocols is considered equally performant. There is no inherent, from a performance perspective, of one protocol being faster than the other. Now, there's specific protocol limitations based on just the protocol itself, but nothing within VAST that says, hey, NFS is always going to be 2 times faster than something else for that. They're all equally performant. We're not using gateways, things like that. And under the covers, within the element store, all of the protocols, all of the permissions management, all the things there are all stored in a protocol independent fashion, which allows us to go through and give the same access to data or the same access to data for a user, regardless of the protocol that they're using. So we have to go through and we have to talk about a few things with that. First off is user identities. We have to be able to get user identities from different providers for this. So we support Active Directory and LDAP to establish those identities for different users for that. And we can stitch those together in various different ways to go through and represent a user, so we know their Unix UID number, we know what their S3 access keys are, we know what their Windows SIDs are, and all their group memberships together to facilitate them accessing the same data from any protocol on the system. So that can be a little bit complex. We've talked about that with other webinars, so I'm not going to go through that here. But this is what we go through and do. We do abstract these a little bit internally, where we store things as a VAST ID for this, and we'll go through as we encounter new users. We'll do all the lookups for the users as we encounter them and establish these VAST IDs. And a user will have multiple VAST IDs in order to establish their identity for these here. And this kind of an internal example, a little bit as to how we represent some of those. Not something you're going to be touching really all the time or really at all as an administrator. You don't have to deal with these, but it kind of gives an example that the permissions that we have here are basically a superset of all the permissions that we have within the system for all the different protocols. And we use these security flavors to control those. So, the common question that we have when we start talking about multi-protocol is, how do you handle the different permission lines? NFS v3 really has no notion of what an SMB style ACL is. Windows doesn't know what a POSIX mode bit is. Windows creates files differently than what NFS does. NFS doesn't necessarily know what an S3 identity policy is for that. Or the common one is, well, if I do a chmod over NFS, what does that do to my SMB ACLs? So the security flavors within VAST are used to determine the permission checking algorithm, permission model that is used for that. So again, are we using just mode bits? Are we using identity policies? Are we doing SMB ACLs for access? It also goes through and determines which protocols are able to set permissions. So if I want to use just an NFS model, I may want to just limit NFS to go through and be able to set permissions. SMB will still be able to read files, over Windows, but ultimately you can't change the permissions from SMB because SMB doesn't understand POSIX mode bits, or vice versa. Maybe I want to control my permissions from SMB, but I still want access over NFS. We can still read and write. It's just, where do we want to control the permissions from? And that's what we use with the security flavors. So I'm just going to iterate through these, very briefly with what all these entail. So we have four main security flavors for this. The first one is NFS. Again, this is going to be your traditional NFS or your Unix permissions for it. So owner, group, other, read, write, execute for each one of those. We do have the option of supporting POSIX draft ACLs. These POSIX draft ACLs are something that we're adding on to NFS v3 to add some additional flexibility, give us some ACLs in there. Not really common across the industry. That's why it was never really fully ratified into an RFC, but we do support those if you wish to do that. We can go through and do with this flavor. We're able to do NFS v3, NFS v4 1 access, SMB access, S3 access. But with this, ultimately your permissions and the granularity you're going to have is going to be limited to those three three things. Are you the owner of the file? Are you the group owner, part of a group that is the group owner of the file? Or are you everyone? And then you're granted read, execute, read access, write access, or execute access on that particular file or directory. When we go through and we only allow for changing permissions over NFS with this flavor, again, you can still access data through the other ones. But if I try to do something that changes permissions from, let's say, the SMB, or I try to go through and I try to do something from S3, I'm either going to get an explicit error saying you're not allowed to change permissions, or it'll just silently fail. Depends on the protocol you're using. Some of them behave differently if they get an error versus if you just say, yeah, okay, you attempted and it didn't succeed, or looks like it succeeded and went from there. So the next one is SMB. SMB is going to be more of your NTFS style. So again, you'll have your full inheritance rules for that. You'll be able to create files over NFS or over SMB or over S3 for those. You'll be able to access those there. The file creation will be a little bit different if you're doing things over NFS, because the permissions that are going to be set on the file when you create it are going to be governed by what is inherited from the parent directory. When you're looking at things there, then your permissions may look a little strange in the sense that NFS, especially NFS v3, doesn't have the ability to interpret inheritable ACLs the same way that SMB represents them. So you may be looking at a file, it may look like you have no permissions for the mode bits, but you'll be able to read right to that file because there's some ACL that's allowing you access. If you have programs that want to check the mode bits to see whether they have access before they attempt writes, we do have some settings to go through and change how those are represented, change how those are presented to allow for that. But generally we don't have to worry about that too much. We can do an SMB protocol, we can do NFS v3, we can do S3 with this as well. And if I do things and I want to, let's say, do some permission changes from, let's say, NFS, if I attempt to do permission changes from NFS, these permission changes are going to silently fail. For them. We're not going to get an explicit error with the SMB flavor. And the reason for this is if you ever look at how if you ever look at a packet trace from SMB or NFS when file gets created, usually with NFS there's a file create action that happens and there's a permission setting action that happens or permission setting call that does that. And if we errored on the permission setting call, that would break everything on there for break most scripts that are out there. So we just silently fail that for NFS. Another one here is mix last wins. Mix last wins is kind of a catch-all. Mix last wins allows for you to set permissions on anything. So you can set permissions from NFS, you can set permissions from SMB, you can set permissions from S3. Unfortunately, when you start having the ability to set permissions from any one of those or any one of those protocols, you have to be cognizant of what those changes are going to do, because it's very easy to go through and run a chmod, and the chmod command will go through and change all the permissions that are on there, or you'll remove an ACL, and that will affect a whole bunch of other things where the action you're doing might be valid on one protocol but not the other. So mixed last wins gives you a lot of flexibility, but with that there are some controls that you need to establish around those. The last one really is kind of the most interesting one when you think about it in terms of permissioning, and that's the S3 native flavor. So if you think about permissioning for NFS or for SMB, for that you have to go through and do things like a chmod if you or with Windows you have to go through and add an additional ACE if you want to add access to a new group for that, and that may take some time to go through because whenever you change permissions on a parent directory, you may want to go through, you have to populate all that down to the child directories there. So with S3, we can make use of identity policies. So these would be the same types of identity policies that you use for things like AWS for S3, and we actually use the same JSON syntax as AWS does for that. To support the same set of commands, and this not only will apply to S3 actions, like I'll have certain actions that I can do on an S3 bucket, but they will also apply to actions through other protocols, including coming in for NFS v3 or NFS v4.1 or SMB, such that if I want to allow somebody to have access to some data that is in an S3 native flavor view, rather than having to go through and run the equivalent of chmod or adding ACLs, I just need to go through and attach the identity policy or create an identity policy that defines what that user or that group is allowed to do, and attach that identity policy directly to that user or to that group. And they will be granted those not only across S3, but across any one of the other protocols that are out there. There's also some other things here regarding S3 that are a little bit different. S3 really, if you look at it, it's it's a bucket style one with an object where the object name is the entirety, and it really doesn't have directory structures or things like that. But with this here, with other protocols, if the object has slashes in it, we will make that appear like there are directories over NFS or over SMB for those types of accesses there for that. So those are what some of the other protocols are, or so what the flavors are for those, or the options are within the view policies. Now, when it comes down to when you're creating your views or you're creating your view policies, it comes down really, people ask, well, what flavor do I want to choose? If I'm talking about going forward in the future, what flavor do I want to choose? Do I need to make a bunch of considerations for multi-protocol from the get-go? That sounds really, really complex. And it's not really. When you start out, or in most cases when you start out selecting, look at how you're going to be accessing your data. Which protocols are primarily doing the writing of the data, which protocols are doing the reading of the data, and where do you as an administrator want to manage permissions, and which model makes sense. If SMB and you want to manage your permissions from SMB for this, SMB flavor is what you want. If the simplicity of your traditional Unix mode bits is fine, then NFS might be the one that you want. But in the cases of, if you're not sure whether you're going to be putting multi-protocol in, or you just want to do a single view, select the flavor that matches the protocols that you wish to go through and use to go through and do the initial set, and then you can add additional protocols. So you just need to kind of look at that. Most of the time it's very simple. Say I want to have my permissions controlled by this model, and that's what I'm going to go through and use that to determine your flavor. So